All right, so now let's talk about quadratics. Quadratics are any function that has an exponent to the power of 2. If you are dealing with quadratic functions, your main concepts to focus on are symmetry, vertex, which is where your max or minimum would be, and x-intercepts. Another name for x-intercepts is roots, solutions, or zeros. They all mean the same thing. A quadratic function can be present in 4 different forms: an equation, chart, graph, or written as part of like a word problem. So we're going to memorize a few key formulas to understand how to focus on the 2 main concepts and see how they connect through each other through each form. Yeah, just like what we talked about when we went to linear equations. All right, so this is what quadratic equations look like. This is them in standard form. The x-coordinate of the vertex can be found by doing x equals negative b over 2a. And also that's where the line of symmetry would be. So then you can plug back in, and once you get the x value, you can plug back in to find y. You factor to find the solutions, the roots or the zeros or x-intercepts. They all mean the same thing. If it doesn't factor, use the quadratic formula. That does come up on the SAT. So for instance, if you're given y equals x squared minus 6x minus 16, to factor this, you would look for 2 numbers that multiply to negative 16 and add up to 6, negative 8 and 2. Negative 8 times 2 is negative 16, and negative 8 plus 2 is negative 6. This is exactly how your answer would be. To find the answers to this, you would set each one equal to 0. So you would do x plus 2 equals 0 or x minus 8 equals 0. If you do this one, subtracting 2 on both sides, you get x is equal to negative 2. And then over here, 8. Okay, yeah. So then you would have your 2 solutions. Vertex form is when you factor something that looks like this. Sorry, I'm not really fond of this example over here. So vertex form is in this form right here. Your vertex on this one would be 3, negative 25. In chart form, you could see input and then output. So if you look at a chart, you could figure out if it is a quadrilateral. I'm sorry, if it is a if it's a parabola or not by looking at do any values repeat, and is it going in the same, like, is it consistently going in the same direction? So here you could see this is it has 2 spots where it hits the y-axis. So that tells us that this is going to be a parabola. Yeah, so it says for the function g defined above, a is a constant and g of 4 is equal to 8. What is the value of g of negative 4? So that's what it's trying to find. So for this one, you would use symmetry, the fact that 3 and negative 25, x is equal to 3. That's the line of symmetry. You can see that here because then the numbers go back in the other direction again. We should expect the value of y. Then we should expect when x is 1 to be negative 21 as well, because it is equidistant from the line of symmetry. So there's no, the answer is A. You don't have to do any work behind it. All right, let's look at graphs of quadratics. We have, this is the standard form. This is factored form. This is intercept form. So standard form, intercept form, vertex form. So from here, you can get a lot of information. You could see where it crosses the x-axis is at negative 2 and positive 8. Negative 2, positive 8. You can see the vertex is at positive 3, negative 25. There it is. If the graph, so if this graph is positive, it opens upwards. So this vertex is the minimum of the graph. If it were facing downwards, then the graph has a maximum instead. If a is a fraction, this number in front of the x squared, the graph will be wider. If it's a whole number, the graph will be more you You're really only keeping your eye out for the max or min or the vertex and apply the information above. Yeah. Okay. Nature of quadratics. All right. Quadratic formula. Do you know the quadratic formula? There's a great song. X equals negative b plus or minus square root b squared minus 4ac all over 2a. That'll help you remember it. This part, the part in the square root, tells you is called the discriminant. It tells you all you need to know about the nature of the quadratic roots. Okay. So if when you plug this in, you get 0, you will have one real solution, meaning it touches the x-axis in one place, like this one. If you have if this is less than 0, if it's a negative number, then it doesn't touch the x-axis at all. You would say it has no real solutions. For this one, if you have b squared minus 4ac is greater than 0, if it's a positive number, then you have 2 solutions. It crosses the x-axis in 2 places. So if the discriminant b squared minus 4ac is a perfect square, you have 2 rational solutions. If b squared minus 4ac is not a perfect square, then you'll have 2 irrational solutions. All right, again, shifts are super important. You should really try to remember these. They come up very often. So again, if you have f of x plus 3, it shifts the graph up by 3. F of x minus 3, it shifts the graph down by 3. If the x plus 3 is in the parentheses, it shifts to the left by 3 units. And if it's x minus 3 in parentheses, it shifts the graph to the right 3 units. If there's a negative in front, it reflects the graph through the x-axis. These are good things to commit to memory as well, just to know what each one looks like. If you have a line, this is the parent function, y equals x. A quadratic function, y equals x squared. It's a parabola. This is what an absolute value function looks like. It looks like the letter V. A cubic function means it's raised to the 3rd power. It looks like this. And a square root function, the square root of x, looks like this. This is what an exponential function looks like. So if you have the x's in the exponent, this is what an exponential function looks like. So here's a good example of a shift. So here's your original absolute value equation. If it had a negative in front, it flips it, so it would be facing down instead. The plus 5 inside of the absolute value means it shifts 5 units to the left. The negative 2 means it shifts down 2. So from here, it flipped. It moved 5 units to the left and down 2. And that's exactly the function you see here. Circles and Pythagorean theorem and stuff, I'll let you guys review that in your own time. I'm not going to focus too much on geometry right now, though it does definitely come up on the SAT. All right, and we'll talk about this one in a minute.